Welcome back to the Cloudcast. I'm your host, Brian Gracely. And, if you've been following the show for a while, you know that we have been kind of, dealing with and looking at the evolution of, all the folks that are kind of our brethren, which are, people that are doing IT operations, people that are managing systems, people that are building systems. And, one of the themes that we've been trying to figure out for a long time is, how is that type of role, how is that type of environment ever going to get simpler? Because it feels like we're constantly throwing new technologies at them. We're constantly asking them to balance both, kind of legacy systems that have certain characteristics and don't change as much. And we're throwing new things at them that change very quickly, more DevOps, SRE, cloud native types of things. And, we've been looking for a while to figure out like when is this going to evolve? When are we going to start seeing real big changes to this space, take advantage of either new technologies or new process to make it easier. And today we get a chance to really explore that. And we're really excited to kind of dig into what's possible. So very excited to have Sunil Mallya, who is co-founder and CTO at Flip AI. Sunil, welcome to the show. Great to have you on.
Hey, Brian, thanks. Happy to be here. Excited.
Yeah, we're excited to dig in. You guys are newer company, getting all kinds of great press these days, and really excited to dig into it. Before we do, give us a little bit of your background, because you have a tremendous background in AI and in a number of systems. But give us some of your background, and then really kind of what was the motivation for starting Flip AI.
Yeah. I used to be at AWS for about 6.5 years prior to finding or founding Flip. And prior to that, worked at large companies, founded a different startup. All throughout these years, the problem that I faced as an engineer or a manager has been around operations, right? Like, I almost say like, developers love coding. Coding is the easy part, like keeping machines up and running in production. That's the real challenge and the most difficult task.
Yep.
And so that sort of, sort of ties into the motivation of Flip. And, I used to manage a few services at AWS, including Amazon Comprehend. So you run the service at scale, 5 nines of availability at AWS scale. So you can imagine, and I can say, has definitely contributed to hair loss on my side, and lack of sleep for colleagues involved and so on. But that's not a unique story to just me, right? Like, it's a story that's very common across the board, which is
Yep.
running like systems at scale. Takes a lot of discipline, takes a lot of, is very challenging. And so what we found was, what can, as AI starts to disrupt software engineering, the entire SDLC cycle, what is it that, AI is looking at as something that can solve? And coding like is the obvious, sort of the most popular thing. We sort of focused on,
Sure.
well, coding is going to get solved, but what else is not going to get solved? And because, AI is going to code more, what else is going to, happen? And to me, it's just like evolution of, like, as developers, as coding assistants are good, but they're not perfect. Just like, people do Stack Overflow, copy paste, now they're going to just accept whatever your AI coding agent says. All this leads to, more bugs, more production downtime. And for us, it's like, hey, you need AI to fight AI in some sense. So building this automation where when things break, find the cause of that really, really fast was an important thing for to exist. So that's why we built Flip AI. Essentially, the pain that developers have to go through when an incident happens, that is, log into your war room, you're asking your colleagues what's happening. Hey, I find this. All of that automated. So alert happens before you can answer a page. Flip AI has the entire root cause analysis up and running for you.
Yeah. No, that's fantastic. I'm always curious because, as you're starting the companies, you probably have to find and identify what seems like a really big problem. Otherwise, it's too difficult to kind of compete. It looks, So let's start there. As you've mentioned, you've worked in a lot of large environments. You've obviously delivered services as part of AWS to large environments. What was what were sort of the biggest challenges you felt like could really still needed to be solved, but maybe most importantly could AI could do some really unique things in the AI IT operation space?
Yeah, I would say, what we found was operations, of course, being one part, right? The
Sure.
other is testing. That's
Okay.
another sort of prime example of there's not enough testing that happens in any organizations. You're moving fast, breaking things, of course. So amount of testing that you can do, that's another sort of ripe sort of industry or fragment. And I think I don't want to deliberate too much on coding because previous episodes and I think many people do talk about AI and coding, so I'll keep that as a given and sort of park that aside. But there's all these things around coding, right? Like documentation, like testing, and how do you sort of onboard new people to code bases, and then once that's there, finally production, like running production. But it doesn't necessarily stop there, right? Like fixing production bugs is how do you sort of self heal? How do you sort of take a broken system, get to a state, upgrading a system, and then sort of finally putting all of this together into a complete sort of automation package. So I think that's sort of on the software engineering side. That's a sort of a ripe thing or a pain that we saw constantly that you needed a lot of humans to do.
Yeah, no, it makes a ton of sense. Um, as people think about their systems, as they're working in IT operations, there's just a ton of different things going on. There's we always hear there's tool sprawl. There's many teams trying to coordinate
Yeah.
things. You've got different patterns depending on the types of applications. When did you start to think that there was a new approach, a more modern approach that could be applied to this problem, and what was your sort of thinking behind what that new approach could be brought into
Yeah.
these environments?
Yeah, it's very true. We find this with all our customers, large enterprises, Fortune hundreds. Uh, they tend to have like at least 5 to 7 tools, and Gartner and other analysts, the estimation is pretty much the same across, right? So it's a problem of you acquire companies or you give freedom to different teams, and everybody starts using the tool that's best fit, but then now you have to look at multiple sources, right? And this is not while I see this in customers, this is also a issue that I've personally faced, looking at multiple sources and sort of stitching a story together. If you've watched the movie like uh, you know Crash, Babel, or Rashomon, like there's different pieces happening concurrently, but you're sort of like unfolding into like this one connected story, and that somehow hasn't just existed, and every DevOps team does its best to write ops tools and sort of automate things as best as possible, but that hasn't sort of elevated to complete automation. And this is where I think the next sort of piece that AI today has brought, which is the reasoning or the understanding part, and things that humans can do, which is look at logs or look at two different kinds of data and say they're connected together or not connected together, or stitch that story together. I think that sort of promise, we saw technology moving in that direction. And that to me was like, okay, hey, now I think this piece that's hard can actually be done in an automated way. Because previously it was some hacky rules or something that has existed that you would do, sort of in your ops, in your ops scripts. So it's that like sort of inflection, I would say, around 2019, 2020 that we started to see AI do a lot more on the reasoning side. And of course, now with ChatGPT, it just seems like a given that people, this technology, is like a no-brainer. So when we started, it was pre-ChatGPT. We were building our own reasoning engines and so on. But I think around 2019, 20 was like the high point where it started to, well, hey, this whole concept of reasoning can be true, and it only gets better from wherever we are.
Yeah,
that was the missing ingredient.
Gotcha. Okay, that makes sense. So, where do you see, the potential of AI models coming into play here? Is it, you talked about reasoning. Is it more as sort of, assisting, those who are kind of tasked with maintaining the system? So, they're able to have the system diagnose things for them. They're able to ask questions, or are you beginning to see it get into, it sees the system, it reasons over what's going on, it figures out what it thinks, and then takes action. So,
yeah,
where do you feel like we are in that spectrum? Because it's obviously never just one thing, but how far along do you feel like we are?
I think there are two pieces to this. One I would say is there's a technical piece, and then there is a philosophical piece to this, right? Like, so the technical piece, I feel, we are still a few iterations away from sort of like this full automation, right? Like, but I think there's no doubt, like in every system, whether it's all the way from industrial revolution to different kinds of software engineering, I think automation has been the name of the game. And that's not going to change with what we see here. Is you will see systems finding bugs, fixing bugs, auto healing, like all of that, like in the fullness of time, will exist, has to exist, like if history is anything to go by. So I have zero doubt about it. I think it's like how that process evolves, I think is the tricky part, because there's a philosophical aspect to this, which is even if, let's say today the systems are perfect, nobody is going to, well, blindly trust like, oh, well, this black box system or something that's going to go fix it. Just like you wouldn't you wouldn't trust even the smartest intern or junior engineer to deploy, a complex thing for you, right? Like you would still have the necessary process guardrails in terms of making sure things are fine for things to get into production or get something back on track. So I feel that same aspect applies to AI, where trust has to be established. And only when the humans or the team starts to trust that, hey, the system, is one of us and can follow process, best practices, then I think the whole sort of automation comes. So what that means is today it is largely an assistant sort of play in terms of augmenting questions that you may have, or whatever you're thinking, whatever analysis you may do, being automated by the AI system. And I think that probably is also the right approach, given the skepticism that all of us have around AI. But I think one of the things I would say is like we at Flip have embraced that. And one of the biggest things that we do is when an RCA is produced, it's not about, hey, here's the answer. It's almost like, well, I worked with AI for 15 plus years. It's going to get some things wrong. It's never perfect. What you can do is still be helpful and guide the user and be that assistant. So everything that Flip produces is actually grounded in evidence. It says, hey, I predict that your database is having this issue where because it's running an unindexed query, here's why I think it's an unindexed query, or here's why your database is getting locked up. All of that evidence is actually produced as to how we came to conclusion. And that, I think, is part of that trust building that I was talking about. And I believe all systems will follow suit in getting to that sort of trust building to automation phase.
Yeah, no, it makes sense. I'm curious, and I asked this almost sheepishly because you've got just tons of AI background, and I'm still learning and evolving in this space. In in many of the pre sort of Gen AI systems, it was a long process to train these models, like data scientists sort of locked behind doors building these things. We're now seeing with these Gen AI models ways in which people can kind of bring their own data to them, right? Whether it's RAG or some other way of doing tuning or prompting. How, are your systems designed such that most of what they would need to be successful are sort of built in, or is there an expectation that they can go in and sort of dynamically learn from specific customers' environments to be more tailored to what they need to do, or what their environment looks like?
Yeah, I mean, you bring up a good point, right? Like if you think about historically, training a model has been extremely tedious. In many ways, it is still, but it's gotten so much better because of newer models, architectures, and so on. And with these foundation models, right? Like you get this really good, as the name suggests, is a good foundation. Like it understands, has a representation of the world, and that can be used by us. And what we do is, in our case, because these are, whatever models exist today are more general models that have some coding abilities, because code, like, I mean, guess what? Developers understand code better than they understand like English, I would say. So they almost like, it's a good way to understand how these models sort of perform. So in our case, it being DevOps, like the domain that we operate in, these models have some idea of DevOps, but not necessarily all of the knowledge. So the first step we do is actually train the model on like 100 billion tokens of like DevOps data, so that the models are really good at understanding DevOps. Like, the name Redis means something to our model, or when you say cloud or some certain words, it actually understands it's not like the rain cloud. It's actually the system, and so on.
Sure.
So it's got that contextual knowledge, and what we have done is using that, and we've trained this on all of the DevOps data, like logs, events, traces, metrics. So it understands when it reads a CPU graph, it looks at logs, it understands that fundamentally. And that is like the foundation that we have built. And now we bring in dynamically the data that we need to operate on. So as an example, right, like when we deploy in a customer environment, we've never seen like the logs in that customer, nor the actual graphs and so on. But the model is able to pull in this data and interpret it, because it's been taught to reason. Like, hey, when you look at like a request graph, a certain load balancer graph, a Redis graph, a database graph, like what does it mean? What do those numbers mean? What is it individually, but also collectively, right? Like, so when you see a CPU spike on Redis and you see certain messages in the logs, how do you connect the two, right? All of that reasoning is built into that model. So to your earlier point of like a RAG, in many ways, our system brings that knowledge and it retrieves the data it needs to operate on, makes the inference as to, all right, this is the observation, here's the next query I need to write, and the next query I need to write, etc., until it has enough of the information to say, hey, this is what is causing the first problem that we saw in your system. So sort of to summarize, right, like to your point, like we do a lot of the groundwork in terms of making the model be available to understand all the things that are happening in your system. So the customers don't necessarily need to train on anything specific, right? The models come, like, as we say, like zero shot. They're able to interpret data in your environment. And of course, like as you go into a more complex environment, you're going to have logs and things that you might have not seen. So Flip does provide a facility to train on your data, right? So our models can get really, really better on your data. But I think, one of the challenges, if I roll back time, has been training models on customer data, and you needed lots and lots of it. Now, the barrier to that has reduced because of these foundation models, and what we have done with getting that base level of domain knowledge up there so the models can perform out of the box, or tune with low level of data and get there.
Yeah. No, that makes a ton of sense. And again, I think like I mentioned, the kind of the understanding of how far we've gotten from building your own models to these foundational models being starting points is huge in terms of cost and time and resources it takes to operate them and so forth. I want to talk a little bit about AI agents and what you guys do with them and how could they can accomplish things. Can you kind of walk us through how you think about agents, like how they're deployed, and then, what are you telling them to do, in conjunction with the teams that are they're there to help and to assist?
Yeah. Agent, I come from a reinforcement learning background, so it's like I've got this reinforcement learning flavor of like agents. So the way I sort of think about agents is here's a system that's interacting with the environment, and it actually gets observes the system and get rewards or sort of signals from the system as it navigates through the system. And the part of this agent is to maximize the rewards it can capture, right? So to me, like that's sort of the definition of more like the old school sort of way of thinking, I would say. And if I apply that to sort of agentic workflows, or to me, like agentic is a better term in terms of like they're exhibiting autonomous sort of behavior. They're getting signals from the system, and they're taking actions, and ultimately achieving a goal, right? Like, so you're trying to, and it can be, varied, right? Like, which is like, finish this test case for me, or change the code in a matter that it passes all the tests. So in our case, the high level objective is, I have an incident, and there's an incident description. Now go figure out or synthesize information to objectively, describe why this incident happened, right? Like, or is happening. Like, that is the goal that, Flip agents have. And one of the challenges, like initially we started to build these sort of single agentic flows. And what we figured out was, that was pretty challenging, and for a complex problem like this, it was not the right approach. And it almost, it's a one-to-one mapping of, like, I like to, when I've built like very, very different systems in my experience. I've built like systems for medical systems. I've built systems for the NFL, actually, like watch, very, very different, like autonomous cars. And to me, it's always like, how do you solve these different problems is you have to mimic human behavior. So that's like my hack or fallback. So what we saw was, like, when we actually solve incidents, it's never a single person, right? Like, you get into a war room, you're asking the database expert, the caching expert, the file system expert. You're asking everybody like these sort of questions, and you're getting like answers back from them, and then you're stitching that story. And so we sort of quickly realized that a single sort of agent we need a better framework. So we came up with this framework we call as like a director, actor, agent framework.
Okay.
And agent, like, so we sort of decomposed into like agent being a very targeted, like it does one thing and it does one thing really well. Like, it's like, write a Splunk query, go get me RDS data, summarize this for me, and so on. And then we started to build more of these actors. So think of them as an orchestrator and a leader, and for agents. So like the war room experience, these agents need to cooperate, right? The database like agent needs to coordinate with the caching agent, and so on. So these actors actually start to cooperate with each other, or sharing information, and then building a better understanding of the system. And then you have a more higher level abstraction where you have a director which sort of orchestrates these actors in turn. So it's like, three levels of, or two levels of orchestration that's happening. So when an incident happens, what we do is we generate like a playbook on the fly, and that playbook has certain steps, right? Like actor one, do this, actor two, do this. And then they gather information, and then you decide, oh, I need to invoke actor number 99, and then so on. So it's sort of this dynamic process of finding information and then acting on that information. And to achieve that with a single agent was just not possible because of different, agents you need to interact with different modality of data, but you also needed to interact with more complex scenarios and architectures as well. So that's just to give you a very high level flavor of how we sort of crack this agentic workflow.
Yeah, no, it's interesting. It's I'm always fascinated when it's, how do we mimic not sort of maybe a repeatable process, but something that involves people, which has a bunch of variables in it. So very, very interesting. I kind of want to ask one last question, and then I'll let you go because you're obviously busy, building and running a company. Can you give me an example, or kind of walk us through an example of some of the companies that you work with? How do they start to engage the Flip technology? What are some of the things that they see in terms of new behaviors and benefits, and what's the Flip experience you've seen for companies you work with?
Yeah, I think all our customers have been excited to adopt the new technology and starting to see tangible benefits of solving incidents. We have customers that have SEV1 incidents that get debugged in a matter of 5 to 10 minutes, right? And these are company halting events, right? So every minute that is saved is worth its money in gold. So that's that's on the sort of extreme side of SEV1 incidents. But on the major or the regular operations have become cleaner. So if you think about, companies usually spend 30% of their time, right, developer time, on just operations, and we've been able to reduce the amount of time that our customers spend on operations, so people can do better things, right? So that's been a big win. The other sort of part and sort of a pleasant consequence of what and how Flip has been able to do is actually up-leveling the developers or SRE personas, because Flip, like I mentioned, everything that Flip does is grounded in evidence. So Flip actually surfaces interesting evidence, and as junior members sort of start to engage in this or read the Flip RCAs, they're like, hey, well, I never knew this system was connected to this. I never knew we had this level of telemetry to dive into. So it's been educational, and what that allows is, sort of, it's like rising tide rises all boats, and in that sense, the knowledge that Flip has been able to surface has actually helped developers and SRE to get better information regarding their system and up-level their knowledge of the system. So overall, it's been exciting, and I'm happy to give developers more sleep because there's nothing. I've lived in those shoes of those 2 a.m. Pagers going off, and you having to rub your eyes or then get on that bridge to fix things. It's never been easy, and to me, it's building this for our previous lives. That's what I tell my team.
Yeah, no, we always love talking to folks who, have lived it, have been in the trenches, doing this, and look to build some things that would have made their lives easier if those tools had been there. And it's always fascinating what happens when you start to unlock information, you make it available to people, and they start to really see what's actually happening, whether it's under the hood or relationships between multiple systems. It's you start to see some pretty incredible things happen. So
yeah,
listen, Sunil,
we actually have I was gonna say we actually have a little flip instance that debugs our production flip instance, right? Like,
oh, very cool.
You gotta use your system that actually ends up providing a lot of training data and scenarios for us to get better. So we sort of you dog food your own thing that you're building.
Very cool. Very, very cool. Well, listen, we're going to put some stuff in the show notes. If folks want to follow up with you, we'll put some links in there that they can get in touch with your team, how they can experiment with the platform and so forth. But thank you so much for taking the time to sort of educate us on what's coming next, what's possible in making the challenges of IT operations easier, and like you said, kind of unlocking some information for developers as well. So exciting to see where AI is being applied. It's not just chatbots. It's hopefully going to make a lot of IT professionals' lives easier and more robust. So thank you so much for the time today. Folks, with that, we're going to wrap it up. On behalf of Aaron and myself, we want to thank Sunil for giving us some valuable time out of his day. Thank you all for listening to the show. Thank you for continuing to help us grow the community and tell a friend about the show. So if you have any questions, as always, show@thecloudcast.net. You can drop us a line, drop us a question, let us know what you'd like to hear about. But with that, I'll wrap it up, and we will talk to you next week.